and the action potential moves down the axon. Calcium channels open and allow calcium to flood into the axon. The calcium moves down the axon terminal to the acetylcholine in the synaptic vesicles. The calcium pushes the synaptic vesicles holding the acetylcholine to fuse with the terminal cells. The synaptic vesicles holding the acetylcholine fuses with the cell membrane, and the acetylcholine is released into the synaptic cleft. The acetylcholine is picked up by the receptors of the motor end plate. The acetylcholine is picked up by the receptors, the motor head end plate of the skeletal muscle. This causes the sodium-potassium channels to open up, and allowing sodium to enter the muscle fiber. So the increase in positive ions entering the cell initiates an action potential on the sarcolemma. The action potential travels down the sarcolemma and enters the T tubule. This releases calcium into the T tubule. And the calcium comes from the terminal cisternae, which holds calcium of the sarcoplasmic reticulum. So the calcium moves into the over the filaments because it's been sequestered by calsequestrin, and it bonds to the troponin, pulling tropomyosin off the active sites that are on the actin. So what you see here is the myosin heads in the low energy state. They have moved the active sites, releasing the ADP into the system, moving the thin filament over the thick filament. So now we have ATP moving to bond to the low energy myosin heads. So the ATP bonds to the myosin heads, and then the heads become energized and